Today, we will be dealing with mechanical properties of solids, which is the first chapter of part 2 of standard 11. In this chapter, we will be dealing first with elastic bodies, then plastic body, stress, different types of stress. So, first of all, I will explain what is an elastic body. For that, I have a rubber band with me. I am going to apply a force on this rubber band. So, when I stretch it, this body is getting deformed. So, the force that I apply is called the deforming force. When I apply the deforming force, there develops a force which is trying to bring this rubber band back to its original position if I am not stretching it beyond its limit. So, such a force developed inside this body which brings this body back to its original position is called a restoring force. So, we have studied about two forces. What are they? They are deforming forces and restoring forces. And from this example, we have understood that this deforming forces is an external force and a restoring force is the force that is developed inside a body, and it depends upon the property of that particular body. So, if in the case of an elastic body, the body which regains its position or regains its shape, even though deforming forces are applied, when deforming forces are removed, it regains its original position or its configuration. So, such a body having that property is called an elastic body. So, there can be a property assigned with that called elasticity. So, that is the property by virtue of which the material can be they can regain its original position even when the deforming forces are removed. Okay, so can you list some examples of elastic bodies or elastic substances? Phosphor bronze fiber is an excellent example of an elastic substance. Now we are going to explain what is a plastic body. So it is actually the opposite of elastic concept. Plastic body is a body which cannot regain its original position even after the deforming forces are removed. For example, our clay, mud, then wax, these are all examples of plastic bodies where when we apply a force they get deformed, permanently deformed, so that we cannot regain its original or they cannot regain its original size. So such bodies are called plastic bodies. So now we will explain what is happening when some forces are applied on elastic body. Let us look at it very microscopically. We know that all the bodies consist of atoms and there is some interatomic space between these atoms and they are fixed in certain pattern inside, so that when we apply a force, what happens is that for elastic bodies, these interatomic spaces will increase, and after the removal of this deforming force, it will come back to its original position. So the microscopic theory of this deforming forces or elasticity is that when a deforming force is applied, what happens is that the interatomic distances changes for some time. For plastic bodies, it changes permanently, but for elastic bodies, it will remain after some time, after the removal of a deforming force, it will come back to its original position. Next, we are going to explain the concept of stress. So we know that when we apply a force on an elastic body, what happens is that the body gets deformed. But there is some restoring force developed inside the body so that it can come back to its original position. So the concept of stress can be defined as the deforming force developed inside a body divided by the area on which this force is applied. For example, I'll take the example of a cylindrical wire. When I apply, it is elastic. When we apply a force like this is our deforming force, and it develops a restoring force also inside so that it can go back to its original position. So stress can be defined either as deforming force divided by the area that we apply this force, or it can either defined as stress is equal to the restoring force developed per unit area. So anyway, when we write this equation of stress is force by area. So as we know, when we write the equation, we have to look for the unit. So how we can write the unit? Stress is force by area. So going for the unit, force is having a unit Newton. Area is having a unit meter square. So the unit of stress is Newton per meter square. So let us understand this concept with the help of a small numerical example. For example, a wire is given with an area of cross section some 2 meters square and a force of 50 Newton is acting on it. So if you want to find the stress, what will you do? Stress is equal to force by area. So what is the force given? It is 50 Newton. Area here, it is the area of cross section. It is the area of cross section where this 50 Newton is applied. So 50 divided by 2, your answer will be 25 Newton per meter square. You know that this Newton per meter square is otherwise called Pascal. You have to note that when you write the unit, this is Pascal. P should be small, or it can be abbreviated as PA. Pascal. So Newton per meter square, the unit is called Pascal. It is abbreviated as PA. So it can be written as 25 Newton per meter square or 25 Pascal. Okay, here since force is involved, we may think that this stress is a vector quantity. But you have to note, children, that stress is not a vector quantity. Please note, stress is not a vector quantity, because this force cannot be assigned with the direction. This force can come from any direction, so that a specific direction cannot be assigned to this force. So please note, stress is not a vector quantity. Stress is a scalar quantity. Now we are going to explain the types of stress. The first type of stress that we are going to explain is normal stress. The word itself gives you the idea. Normal, it's something. Normal means perpendicular. So for example, again we are coming to the case of a wire, cylindrical wire. Look, when I apply a force like this, what happens is that we are applying the forces from both ends. What happens? There is a change in length, right? But this force is acting perpendicular to the area of cross section. That's why this stress is called a normal stress. So, when a normal force is acting per unit area of cross section of the wire, such a stress is what is meant by a normal stress. This normal stress can be categorized into two. One is tensile stress. tensile stress that I have already drawn here, because when we are applying a force in both directions, there is an increase in length of this elastic body. So tensile stress usually produces increase in length. So when you go for numerical, sometimes the hint given in the question will be tensile stress. There you have to understand that there is an increase in length of the body. So this tensile stress can be written as stress is equal to simply the force applied by area. Force on a cross section divided by area, where the force is normal to the area. And the second type of normal stress is what is meant by compressional stress. What is it called? Compressive stress or compressional stress. Compressive stress. What happens in a compressive stress? Here, when there is a body, elastic body, and when we are applying a force like this, these two forces will produce a decrease in length. There also the stress is written by force by area, and this force is perpendicular to the area of cross section. That is why the word normal, same equation is there, only the effect is tensile stress produces an increase in length, but a compressive stress produces a decrease in length. But you may not hear that whatever forces that we are applying to this body, this net force is zero. Hence we can say that even though we apply two forces, two equal and opposite forces on the sides, it will produce a change in length. That you have to note. And this normal stress is otherwise called longitudinal stress. What is it called? Longitudinal stress. So taking a recap, normal stress is the stress where the force applied is normal to the area of cross section where it is applied. It can be categorized into two, tensile stress and compressive stress. Tensile stress produces an increase in length and compressive stress produces a decrease in length. But basically, so what happens? You can just zoom in and see what happens at this edge. When I apply a tangential force, what happens? This edge gets deformed in an angle. So I will just draw it. Listen, if there is a block here, our book, we can consider our book. It was like a fixed thing at the bottom where I applied a force. So what happened is that it get slightly deformed like this, so that the edge got displaced by an angle theta. So let this be L. I have applied a force on the upper surface so that the book get displaced. What happened in this case? There is a change in shape without a change in volume. So, but what type of a force I have applied? A tangential force. So, tangential stress can be defined as the tangential force applied per unit area. So, here also, when we write the equation, tangential stress has a equation like force by area, but this force is only tangential force per unit area. So this is called tangential stress. Now we are going to explain the third type of stress. That stress is called bulk stress, or it is called hydraulic stress, or it is called volumetric stress. So what happens? Let us consider the example of a bubble, and we are going to apply a force uniformly. So we are trying to squeeze it. So force is applied uniformly over the surface. So when the force is applied uniformly over the surface, what happens? It gets squeezed. So there is a change in volume happening here. Change in volume happening here. So a bulk stress is the stress when force is applied uniformly on the surface of a body, which can increase or decrease. Usually when we apply it from outside, which can decrease or change the volume of the body. So here there is no change in its overall shape. The circular drop will remain circular, but there is a change in volume. So such a stress which can change the volume, and it is when the force is acting uniformly in all direction is called bulk stress. So again, coming to the equation of bulk stress, we will write that it is force by area only, but there are different types of forces that we were using in this all types of stress. So this bulk stress is otherwise called hydraulic stress, or it is called volumetric stress. So before concluding, let me make you understand what all are the effects of stress. In the first case, what was the effect of stress? It changed its length. In the second case, when we studied tangential stress, it changed its shape. Here there is no change in shape, as overall circle remains circle, but there is a change in volume. So taking the recap once again, the types of stress are normal stress, then tangential stress and bulk stress. And all of them have the same formula. We have to look for the force, we have to look for the area of application where the force is applied.